right, good. So let's start with mean. Of course, yesterday we defined mean as the simple average, and basically we have population mean, and also we have that is a sample mean. Okay, so for sample mean, let's start with sample mean. Sample mean. Sample mean is always denoted as x bar. Okay, or expectation of what when we are talking now to and that is derivatives, and that is we have integrals and derivatives. So we also have what we call expectation of x, and expectation of x is basically mean. Okay, and then we also say that second derivative of x, it is what? It's variance. Okay. Then the third derivative, we usually call it skewness. Okay. Skewness is the third derivative of expectation of x, and the fourth derivative, it is kurtosis. You can go and confirm that. Kurtosis. Yeah. Okay, you can go and confirm that about those derivatives. So basically what or the point of concentration here, it is now that is how we denote simple mean. So in case maybe you find a question that is to find the x bar, okay, or y bar, okay. Basically, this means this is the what the mean of x variables, okay. X variables that is taking where like x variables. When I say x variables, I mean x i's up to n, meaning I can take what? Can take 1, 2, 3, up to n. Okay? Remember, we are talking about what? Sample mean. That's why I've denoted even n with what? With a small, that is n. Okay? So x bar basically it is what? It is the sample mean. Okay? What about population mean? We also have now population mean. Okay? Population mean. Population mean. So population mean is denoted by mu. Okay? We use mu to denote population mean. Okay? All right. So in this case, we are going to I'm going to illustrate how we can calculate how we can calculate a sample mean. So let's assume you are given x variables, like we have x1 or x, yes, let me say x1, we have x2, we have x3, and maybe we have what? X4. Okay? X4 can be what? Can be values. Okay? So, how can we get the mean of what? Of all these x variables. Okay? So, with that, we are going to say x bar will be given by now the total sum of these x values. So like it will be xi plus x1 plus x2 plus x3 plus x4 divide by what? Divide by the total sample size. Okay, and when the sample size for this maybe data set, it's 1, 2, 3, 4. It is 4. Okay, yes. So divide by 4. So basically, this is the that is the formula for that is for x bar or for the sample mean. Okay, we can also try to try to make this formula a bit that is smaller by use of summation sign. Okay, by use of summation sign. So we know that this value, like x1 plus x2 uh, plus x3 plus x4, okay, we can denote this as maybe x we can denote this as xi, okay, and in this case we can say that xi is taking values that is 1 2 3 up to what, up to 4. Okay, so with this I will let me just insert a new uh, all right, good. So in this case, we can also as well describe maybe our or this addition into, let me carry that here. So we can say it is now I1, okay, plus x1 plus x2 plus up to xn, okay, and our n here it's what, it's 4. Okay, so with that we can now try to use the summation simple just to summarize this. So to do so we are going to say this is the same as saying a summation of xi, whereby I is taking values 1 up to what? Up to n, okay? Uh, that is summation of xi's, sorry, summation of xi's, where I is taking values from 1 up to n, okay? And we already know our n, okay? So in this case, it will be summation of xi's, okay? Where I ranges from 1 up to what? Up to 4. Okay, so with this now, we have to, of course, for it to be mean, we have to divide by what? We have to divide by that is the total sample size. Okay, so with this we can conclude that our x bar can also be calculated by this formula, that is summation of xi's, okay, where I is taking values from 1 up to what, up to 4, divide by what, divide by n, okay, and our n we know that is what, that is 4. So it will be summation of xi's, I ranging from 1 to 4, divide by what, by 4. Why? Because we only have 4 values in our example. So let's assume maybe our values are maybe 20, okay, 30, okay, we have 50, okay, and we also have 60, okay. So we can compute now our what, our mean. So our sample mean, that is x bar, will be 20 plus 30 plus 50 plus 60, divide by what, divide by 4. So our x bar will be this is 50 plus 50, that is 100, 160. So it will be 160 divide by what? Divide by 4. And 160 divide by 4, it's what? It is 40. Okay, so our x bar will be what? Or our sample mean will be what? Will be 40. So generally, this is how we calculate what? This is how we calculate that is sample mean. Okay, Yes, so let me take you now to the slide and maybe we can go through together the steps to calculate what mean. Even though I've already illustrated here, that is all the steps, but it's good also we compare the notes with what I already know. So count the number of the values of the data values, let it be what? N. So basically n is the count of all the numbers which you are using to calculate what? Your mean. Otherwise n is the what? Is the sample size. Okay, n is the sample size. All right, then I hope we are all together, right? Are we together? All right. Okay, good. Yeah, seems we are all together. So in case of anything, or in case maybe um, uh, you don't capture a specific concept, please let me know. You can always raise your hand so that I can repeat. And also, in case maybe uh, I'm too fast, okay, you can as well reach out to me and tell me maybe to slow down. Okay. Yes, I know sometimes I can go marathon. Okay. Yeah, but you are always free to let me know. All right, good. So the first thing is count the number of data values. Okay. So, and let it be what? Let it be n. So n basically is our sample size. Then add all the data values. Let the sum be what? Be s. Okay. So let's assume we also have this formula. So we now have what? We now have n, which is the sample size. Sample size. It is our n. And also we have sum or total. Okay, total or the sum of what? Sum of all the that is all the values. Let's call it s. So our mean, that is x bar, will be what? S divided by what? Divide by n. So then mean will be sum of all data values, okay, divide by the total number of what? The divide by the total number of values. So basically, that's how we calculate what? How we calculate mean. So this it's just like manual way to calculate what? To calculate mean. But now when we will be doing now the practicals after that is we are done with these slides before we can go to move to another topic. We shall now use Excel data, maybe or a real data set, okay, and be able to use Excel inbuilt functions to calculate what? To calculate the mean, okay. So don't confuse this. We are yet to come to practicals. Yeah, so this is just illustration for a better, that is for better understanding. All right. I hope we are all good with mean before I can move to the next measure. All good? All good, people? You can just show me yes, a thumbs up. Yes, Naomi?
No, sorry, by mistake. It's all good. I've understood. Thank you.
Okay, good, good. Okay, I can see Ain said I broke up for a few seconds. You can always chat me over WhatsApp in case maybe you know these networks sometimes might decide to misbehave. Okay, you can always text me over WhatsApp in case maybe I you lost me. Okay, yeah. So okay, okay. Let me check on my internet. Can see seems we are having some connection issues. Okay, am I now audible and clear? I've just switched my network. All right, nice. That's okay. Good. Good. So what I was saying that don't confuse this illustration, okay, with practicals. This is just an illustration. We are yet to do what? The practicals. So this is for better understanding. Okay. So I'm going to move to the second measure. So the second measure, it's what? It's the median. And the median, I guess yesterday I illustrated with two, that is examples. When we have odd number of values, okay, and then when the count is odd, meaning let's assume we have 1, we have 2, we have 3, we have 4, and we have 5. Okay, you can see the count is what? Is odd. Okay, so if the count is odd, I say that we will take what? The middle value of the what? Of the sorted, that is a set of what? Set of values. Okay, all right. But what if maybe we have like an even count of values? Okay, let's assume we are having 1, 2, 3, 4, 5, and 6. So in this case, we usually take the middle two values, okay, add them and divide by 2. Okay, so like for this case, we'll take the third, okay, value plus the fourth value, okay, divide by what? Divide by 2, where it will be 3 plus 4 divided by what? Divide by 2, which will be 7 divided by 2, 3.5. So our median will be what? 3.5. Okay, so don't forget about that. So basically that's about that is median. Let's see step by step how we can calculate median. All right. Okay, good. So median we said is the middle value of the sorted data set. Okay. Yes. And this is how it is calculated. So first of all, you arrange the data set in either increasing or decreasing order. That is also the ascending or descending order. If the data set has an odd number of values, that is n is odd, okay, like for example n, our first n in our illustration, it was 5, and our second n, it was what? 6. So if n is odd, then you take the middle value. If n is even, okay, then you take the two middle values, add them and divide by what? Divide by 2. Good. So if the data set has an odd number of data values, n is odd, then the middlemost value of the sorted data is computed as what? As mean. In other words, that is the data at n plus 1 divided by what? By 2. So we have the second step. In case if the data set has an even number of data values where n is even, then the average of the two middle values is computed, okay, is computed as the median. Okay, the average of the two value is computed as what? Is computed as the median. All right, that's all about median. Let's go to mode. So under mode, we say that mode is the most frequently occurring what? Value. Okay, and how do we calculate mode? So for steps to calculate mode, use the tally marks to identify how many times each data value occurs. In fact, we don't have to calculate that is mode for symbol data. If maybe we have 10 values, you don't need even to do calculation. It's a matter of observation. Okay, but remember, also a sample data, we can have a sample data of that is 1,000 entries. Okay, but now with these 1,000 entry, you can't go value by value, checking what? Checking that is which is the most occurring value. Okay, but now we can do what? We can now use the Excel function. That is, we have the single mode, okay, and we have the multiple mode function, which at least can give us or can return that is the mode in a very easiest way and also within a short time. That is regardless of the size of your data. Okay, so the data value with maximum tally is what? Is the mode of the data set. So we shouldn't have any issue when it comes to the what? To the that is the mode. Okay? Yes, we shall cover much or we shall understand more about it when we will be doing what? When we will be doing our that is practicals. Good. Now, okay, I have another thing. I have another. Let me add something under mode. So let's assume we have this data set. Okay, so we have these values. Okay, we have 1, 2, 3, 2, 5, 6, 5. What is our multiple mode in this that is in this data set? Someone? I need the multiple mode. Someone? Someone, please?
I believe it's 2 and 5.
Yes, the multiple is 2 and 5. What if maybe we now decide to run maybe a single mode, okay, in this data set? What will be the single mode? If we decide to maybe use the function single mode and on the same data set, what value will it return? Or what will be our single mode? Okay. So in this, I can help. Okay, I can help. So in this case, our single mode will be what? Will be 2. Why 2? Because the single mode will take the first mode, okay, or the first value which is occurring more than what? More than 2 times. So in this case, it will take 2 instead of 5. Why? Because in our data set, 2 is coming first, okay, before what? Before 5. But don't confuse that it in numerical order. No, in fact, maybe let's assume I have 6 instead of 2. So if I that is I run that is a single mode, okay, it will return 6, okay, but not 5. Why? Because 6 is the first value to have maybe to occur more than what? More than twice. So please take note of that. All right. Then we have some examples, no problem. These examples you can go through them on your own. Like for example, let's assume we are considering weight of 5 children in kilograms. That is, we have the first child, sorry, with 36 kgs, second 40 kgs, third 32 kgs, fourth 42, and fifth 30 kgs. Okay, so to calculate mean, of course you will add all those weights, okay, then divide by the total number of students, okay, yes, or the total number of children, and you'll get the mean what? The mean the mean weight, okay. Same to median, you can arrange in ascending order, and then what? Pick the middle value, okay? Then mode, you can check maybe the most occurring what? The most occurring value. Okay, now before we can go that is to the second measure, that is measure and descriptive statistics, we have that is some drawbacks, okay, or let me say setbacks, or um, effects, okay. So in measures of central tendency, you can't use one one measure, okay, to do what? To conclude about your data set, okay. Like for mean, we know that mean is highly that is affected by extreme values, or mean is highly affected by what? By that is by outliers, okay. Can someone maybe explain what an outlier is? Who can try? Outlier, I know you know, I know we have some people who know the definition. Someone can try. I just want to make the class more interactive. Yes, Caleb.
Hi everyone.
Hi.
An outlier is something, or for this context, a value that will be considerably off the central um, average position, or either very big in value or extremely small compared to the rest of the
Value.
numbers
Okay, that's
or
very
values for this
correct.
case.
Yeah, that's very correct. That's very correct. So, outliers, they are extreme, maybe extreme high or low values. Okay, like for example, okay, let me assume in now the weight. Let me take the weight of the that is of the children. Okay, let's assume they are within the same age set. Okay, so you might find from this example, you can see most of the weight is ranging between what? 30 to 40. Okay, it is ranging between 30 kilograms to 40 kilograms. Okay, so maybe we might have let me just add another weight here, like 100 or 140 kgs, and yes, so let me just do 140. Okay, so with this, it will make the mean shift to the what? To the that is to the highest value. Okay, like for example, if we add 140 here and divide now by 6, what will be the value? So we have 180, so we have 180, and then we have 140. Okay, so this is 320. Okay, so let's now divide this 320 by 6. Okay, let's assume we are dividing 320 by 6. Okay, so what will be the value here? We are dividing 320, that is 320 by 6. So what will be the value? So the value will be, let's go, how many times we have, so we have 30, that is 5. Okay, let's say we have 5 in 32, then we'll remain with 20. So you'll get like almost, that is, we are having, um, let's say 53 point almost 25 or 5. Okay, 53 kgs. Okay, so you can see we had the average kg to be what? To be 36 initially, before we added what? The outlier. So once we add the outlier, you can see the average weight has shifted, okay, to a value closer to, that is closer to the highest, maybe weight. Okay, the same will happen when we use a very extreme, that is small value. Like let's say within that these children, we also have that is a child with weighing 5 kgs. Okay, so you can see we'll have what? We'll have our mean shift to the what? To the lowest value, okay, in our set. So this is a major drawback, okay, of the mean. That is, mean is highly affected by what? By outliers. So distribution and mean. So mean, we are saying it is highly impacted by extreme values in the data set. If the data set is symmetric, the mean value is located exactly at the center. Like for example, let's assume that is the example of what? Normal distribution. Let's assume this is a standard normal distribution. Okay, then the mean of this will what? Will lie at the that is at the middle point of maybe our data set, or the middle point of this distribution. Okay, meaning it's like it is cutting it almost into what? Into two parts. Okay, equal parts. So however, in skewed distribution, the mean value is pulled away from the what? From the center. Like let's assume we have maybe that is a left skewness. Okay, so this is kind of skewness. Okay, we have our data is skewed, and we have that is majority of our values lie between here. Okay, they lie between here. Okay, so with this, definitely the mean can be what? Can be that is at the center, but it will be either be drifted to the that is to the left or to the right, depending with what? Depending with the skewness. We shall cover this more when we'll be that is dealing with skewness topic or the measures of asymmetry. So this is just an illustration. Okay, good. The other thing, it's the best measure of central tendency. So mean is preferred, is the preferred measure of central tendency when data is normally distributed, meaning we don't have any outlier. Okay, we don't have any outlier. Okay, so if we don't have outliers, mean is the preferred measure of central tendency. Okay, then median is the best measure of central tendency when the data is what? When the data is skewed, either to the right or to the left. When the data is skewed, then median is what? Median is the best measure, okay, of central tendency. While dealing with the nominal variables, okay, while dealing with the nominal variables, the mode that is the mode is the best measure of what? Of central tendency. All right. All right, that's okay. So maybe let's do a conclusion on measures of central tendency. So we've said that mean, median, and mode are the most important measures of central tendency. Okay, the complete data set may be represented by these values. It is not necessary for mean, median, and mode to have the what? To have the same value, unless we are working with what? A normal distribution or a perfect normal distribution. When we are dealing with a that is like a standard normal distribution, mean is equals to median is equal to mode. Okay, yes, this is one property of what? A normal distribution. Okay, mean is also sensitive to extreme data. Okay, mean is extreme to the that is mean. Okay, I hope someone tried to text me over the WhatsApp. Did you lose me at any point? All right, good. So mean is what? Mean is sensitive to extreme that is data values. It is not wise to take it is not wise to take mean of skewed distribution as the true representative of what? As the true representative of a data set. Median is better way to understand what? Median is the better way to understand skewed distribution. And we say that mean and median can never or cannot be zero unless all the values are what? Are zero. So unless all the values are zero, you cannot get that is zero mean or zero median, because we will never have zero at the what? At the center of maybe your data values. Okay. Yes, then, however, it is possible that there is no mode in that is in dataset. So it is that is it is very easy to or possible to have no mode in the what? In the dataset. All right, that's good. Now I wonder